Hello, it's Keith here, and I'm going to be doing a special episode today. We're not going to be discussing programming, we're going to be discussing 3D. Now, I'm writing a game that uses stereoscopic 3D, Anaglyphs stereoscopy, and this is going to be a retro game, and I thought it'd be worth discussing how you can work with 3D, how you can convert 2D images to 3D ones using normal image editors like Krita or Photoshop if you prefer, and also just discussing the technologies that are currently being employed for 3D and the ones you might be using, and how you can use those yourself and make images for them. I thought this would be quite interesting. These stereoscopic 3D images and technologies are something I personally find very fascinating, and I really just wanted to let you know about them in case they hadn't been something you'd thought about before, and maybe I can encourage you to take an interest in them and have a go yourself, because what I'm going to be doing is I'm going to be showing you how I converted a 2D image, the graphic for my game that I'm working on, and how I converted it into the stereoscopic 3D image you can see in front of you today. Now, the image you can see here is designed to be viewed with Anaglyph glasses, which are the classic red cyan glasses. I've got a pair here, and I've got a much nicer pair here, and if you put these on, you will see that this is 3D. Some images are going into the background and some are in the foreground. Now, the point is this image was converted from a 2D version. I made the 2D version first and then converted it, and I'll show you how to do that conversion today. But the other thing that's important to know is that just because the colors are being distorted here, if we've got better viewing technologies like the Nintendo DS, for example, the original image is still full color for both eyes, so we can create an MPO file and view that on our 3DS in full color. And if we've got a stereoscopic display, like I've got one that's line interlaced over here, we can view that in full color on there. And I'll even show you how to view that in just Photoshop or Krita, how to convert the image so that you can view it without any extra software if you've got a line interlacing screen like that. But first of all, I want to go over to my overhead camera, and we're going to have a look at a variety of the 3D technologies you might have come across. We're going to discuss how they work and some of my thoughts on them, and maybe it'll be interesting. Let's go over and have a look. Okay, I'll just take these off for a moment because I need to discuss them if for no other reason. Okay, so we've got a variety of solutions that you might have come across in the past, from the 3DS, passive 3D glasses here, active 3D glasses, and the Anaglyph glasses, which you will probably know from the old 80s movies, which are a much laughed at technology but have their uses. So we're going to go over these. So the first thing, of course, with 3D technology is it all comes down to showing both eyes different images. Eyes see different images, and that creates a 3D. And one way or another, we need the technology, whether it's the DS or the shutter glasses, to present different images to the eye, and there are different ways of doing this. Now, the classic one is the humble Anaglyph glasses. We've got the very old style cyan red, which are perfectly good. We've got this sort of more modern version, which is the magenta green, and we've got the so-called color code glasses, which are blue yellow. So these all work on the basic same technology. Our eyes see red, green and blue. Now, red light will pass through a red filter, but blue light will not pass through a red filter, and so on. And so basically, by splitting up the color channels, we can create two separate images that will be seen by the different eyes. And this creates perfect 3D if we are looking at a black and white image. But if we're looking at a very bright color image, it starts to become quite uncomfortable, because a naturally red object like an apple will be invisible to the red eye and will be very dark to the cyan eye, and that's the problem. Now, all of these work in exactly the same way. Basically, they've split the red, green and blue into separate components, and they've combined two of the colors together for one eye, and one of the colors is separate on the other one. So cyan is green and blue, and then you've got red here. Magenta is red and blue, and then you've got the green here. And then these ones have the blue here, and the green and red make yellow. So in each case, you've got one color channel for one eye and the other two for the other eyes. And at this point, it helps to know a little bit about how the human eye sees color. The human eye is best at seeing green, it's quite good at seeing red, and it's not so good at seeing blue. Now, this comes into play when you want to discuss which of these is the best and which of these is the worst. Basically, the classic red cyan ones are a good all-rounder. They give reasonable 3D and reasonable color if you make some optimizations. These magenta green, the more modern ones, give better 3D, and the reason for that is they're combining the blue and the red, which are the less good colours the eye can see together, increasing the effectiveness of it, and keeping the green separate, which is the good colour that the eye can see the best. So the overall is that these give very good 3D, although the colour is possibly a little bit worse than these. The cyan lets more colour through, and these possibly give slightly more odd colour effects. The colour code ones, to my eyes, do not give good 3D at all. The blue filter is very dark and there's very little 3D effect. This is almost intentional. They advertise them as being very good for people to view in 2D without the glasses and give 3D when you have the glasses. And the reason they give very good 2D is the human eye doesn't see blue very well, so the 3D suffers. I'm not much of a fan of them because the 3D is so poor. I prefer either these, or if I'm going full out for the 3D, these. So that's my opinion. Now, one other thing to say about colour code is about the patents. They have patents on their technology, but their technology is not blue-yellow anaglyphs. Blue-yellow anaglyphs are not something they can really patent. They've been around forever in theory. The colour code patented technology is a specific formula for converting two 3D images into one colour code thing. So if you combine and alter your channels yourself to make a 3D blue-yellow image, you're not going to be breaching their patents, so you don't need to worry about that. That's the important thing to say about that. So those are your classic anaglyph glasses. They're a lot of fun. I quite enjoy them, although obviously there are better technologies around for colour. Now, one thing that you might have seen, which is may fool you into thinking it's similar, is these, and these are Pulfrich glasses. Now, these came out for the Prince's Trust many years ago. They're fairly, these kind of crop up for very brief periods every few decades. Basically, these allow you to have an image that shows no colour distortion that you would expect from 3D glasses, but they do give a 3D effect. And this is based on exploiting a trick of the human eye. The brain actually responds to dark objects more slowly than light objects, and you can use this to effectively trick the eye into seeing two different images for the different eyes, because if an object is constantly moving, by the time the dark eye sees it, it will be in a different position, and that can cause a 3D effect. If you ever get your hands on some of these, what you might want to do is try playing Super Mario, because you'll find if you run in one direction, the background suddenly goes into the distance, and if you run in the other direction, it starts sticking out in front of Mario, and the 3D makes no sense. It's quite fun, and if you flip the glasses over, the 3D will invert, because, as I say, that it just depends which eye is being delayed, what the 3D direction of movement should be. So, as I say, these work really well for the right video, but the important thing is the video has to constantly move. So you want panning shots where the camera is constantly moving, or rotating shots where you've got an object and the camera is moving around the object, panning around it. And now I've told you that, you actually know more than the camera crew of the special event, because it was horrible. They simply didn't seem to understand how the technology worked, unfortunately. It was very, very disappointing. Anyway, so those are the technologies you tend to see in old videos and on TV and things. We're now going to go into the sort of more modern ones. These are specifically passive 3D glasses like these, and active ones like these. Now, what does passive and active mean? Passive means this has no moving parts or anything. Active means battery powered. These are active shutter glasses. They have a battery in them. And basically the lenses, these are LCD displays like you used to have in your watch before we all had iWatches. But basically these are programmed, and they have a sensor here. This is an infrared sensor. The projector or the TV will send a command, and this will alternately black out one of the eyes with those LCDs, and that means the human eye is seeing two different images. The pros of this is full 3D. The cons is a battery powered device, and also you've got to have a very fast high refresh display, otherwise you're going to either have flicker, or you're going to have, if the black to black isn't fast enough, you're going to have you're going to see part of the previous image when on the wrong eye. These aren't favoured in cinemas because being as they're active and the glasses are quite expensive, they're prone to theft, and also in a cinema environment they've got to wash them after each user, so they're not a fan of them. So the cinemas and some home displays tend to prefer passive glasses, which are these. These came with my monitor, and these came, I believe, from a cinema. I can't really remember. And these are polarizing filters. Now, polarizing filters are a bit tricky. Basically, if I hold these just right, you can see that these two lenses over each other allow light to pass through. But if I move over here, these two are actually blacking each other out. Basically, these are polarized in different directions, and what they're doing in the projection booth is they've either got two cameras or some kind of filter that will go over, and it will alternate between the two polarizations for the two images for each eye. And because of the filters, the eyes will see the two separate projected images, and so that's how these will work. Now, the final kind that you will come across is what's known as a barrier screen. This is the 3DS, and that's what this uses. A barrier screen is it uses a completely alternate technology, really. If you think of if you've stood in front of a metal gate, if you stand in front of a metal gate, the metal gate, because it's in front of your eyes will see through the bars, but each eye will see a slightly different image through the bars because you're looking from a different point. You're seeing into the distance at a different point. And the Nintendo DS has essentially a set of bars in front of the screen. They're liquid crystal, so it can turn them on, and then because the pixels behind are aligned in such a position, the pixels you see will depend on the position of your eyes compared to the bars, and your left eye will see half the pixels and your right eye will see the other half, as long as that barrier is enabled. And that's why you will see the screen get slightly darker when you turn the 3D on as to when you turn it off. And that's how this works, and that's why there is a very fine limitation of the position your head can be for you to see the 3D effect. If you move too far to the left or the right, the effect will be broken, and that's because your eyes are now seeing possibly the opposite pixels they should, because your eyes aren't aligned for that barrier and the pixels behind it. So that's how these technologies all work. Now, actually, ironically, the best one for creating 3D images is these, or one of the other Anaglyph glasses. And the reason for that is these are a very simple technology, and they don't have any limitations like needing the screen to alternate between two images quickly, which you would need for shutter glasses. They don't have any limitations on the position of the pixels, which the passive ones and an interlaced screen would require. So these are very simple, very flexible, and we can actually make Photoshop or Krita show an image in 3D very, very quickly with these, and very easily. And that's what we're going to do when it comes to actually converting our image to 3D. And I will just quickly show you, you won't be able to see the 3D of course, but I will show you the image that I have created, and we are going to recreate today, and you can actually load it in just here. There's the current image, and if I turn on the 3D here, maybe you can just about see that it's moving there as I tilt it. Anyway, the image is being viewed fine in 3D, and it's in full color, and that's the point I'm making today. We're going to be using Anaglyph glasses to make the 3D image, but the final image will not be limited to Anaglyph color. Okay, let's go over to the other screen and let's actually learn what we need to do. Okay, so here's the final image in stereo photo. This is in Anaglyph mode, but this program can do all kinds of other modes. Now, what we're going to do today, though, is we're going to go back to this original 2D image. This was the source image, and I'm going to show you how we can convert that into stereoscopic 3D. So what we're going to do first is we're going to make a copy of the first image. And so if we just go here and we go to duplicate layer, so there's now a second copy here. Now, what I'm going to do now is I'm going to go to properties. Now, this is going to assume you're going to be using red cyan glasses. I'm going to be using my plastic pair here. And so if we just put these on now, if you're using different colors, if you're using magenta green, then you will need to select different options here, but I'm sure you can work out what you would need to do. So I'm going to create the left eye image, and the left eye on these glasses is red. So I disable green and blue here, and I click OK. Now the image has not changed. No, it hasn't. So at first you might think something has gone wrong, but it hasn't. Now what we're going to do is we're going to manipulate the left eye image to give a stereoscopic effect, and it's incredibly easy, and this is what's so fun about this. So suppose I want to make these bats go further into the distance. So I'm just going to select these bats by drawing a box around them, and I can zoom in if I need here. Okay, so the bats are now selected, and then I just need to move the bats on this second layer here, and if I move them to the left, they are going into the screen, and if I move them to the right, they're going out of the screen, and that's it. That's all I have to do. So I'm moving them into the screen, and now they're a little bit into the distance. And I can zoom in, although the 3D effect does get more exaggerated as I do that. So I need to make sure I'm not aligning things to the wrong depths, because I'm zoomed in for some parts and not for others. So I can do the same here for these mountains. If I want these mountains to go into the distance, I can just do that there. Those mountains are now in the distance. I can have this moon, and I probably want that to be even further into the distance, so I'll just drag that all the way over there. And basically I just configure each of these objects to the position just by eye, basically. But you could count pixels if you want to be super precise on it, and we just move all of these accordingly. So we'll put these somewhere about there. Okay, so that's that done. Now what I did for the version you saw before is I made this suck hunt text get progressively more and more into the foreground at a sort of angle, and the way I did this is it's pretty simple. All you do is you select all of the object here like this. Okay, and if I just shift this 1 pixel to the right here, I've selected by that bat, that was a mistake. So if I just undo that and I unselect that bat there, you do have to make sure you don't make any mistakes like that, but you can correct mistakes if you do make them. As you can see, it's not going to take very long anyway. So now if I shift all of this by 1 pixel across, that looks about... So now if I just shift all of this to by 1 pixel across, and now I'm going to deselect part of the text, and then I'm going to shift by another pixel. So I'm moving different sections of this text by different amounts here, and that is going to create the 3D effect. So because different bits are being moved by different amounts, because I'm progressively moving the same section, we are making we're making this part of the image look like it's a sort of diagonal angle coming out to the viewer. And if I want, I can make this part stick especially out to make it look like this stake is really sticking out of this bat here. Now that's a much simpler version of what I did before. I went into more detail, but you can see basically just by moving in one direction, the image goes into the distance of the screen, and in the other, the image comes out of the screen. Now, images coming out of the screen can get quite uncomfortable if the depth is too stereoscopically large. If it sticks out behind the viewer, for example, if you've got a very big screen, that is extremely uncomfortable. But we're just playing around here, so I think this will be okay. Now, if I disable the background image, you can see everything's just red. But remember, this is an effect that's been applied here in properties, and we can turn these layers back on and our full color image is back. And that's the benefit of this. We are using our 3D glasses to configure our 3D, but we don't need to use them if we've got something like the DS or a projector with full color. Our image is still full color, and now all we need to do is we just need to patch up any stereoscopic gaps, because these are gaps that need to be, in this case, just blacked out, but in some cases you might need to draw in bits of background that don't exist that need to. Like, for example, here, I might want to draw in the missing part of the bat here. And just redraw his eyes here and face or something. It's a bit messed up, but as I say, this isn't as well done as the final version in the game will be. But I just wanted to show you just how quick and easy it can be. So there we go. We've roughly done that. Now, as well as anaglyphs, and as I say, if we just go to properties here, we can actually do any kind of anaglyph we want. We can do a green magenta one here, or we can do a color code blue yellow one here, just by selecting these different options. But actually the anaglyphs for the colored glasses aren't the only kind we can support. I've got a passive screen over here that uses interlacing, and we can actually interlace for that. Now the screen I've got is a horizontally interlaced screen, which means that the alternate lines of the screen are sent to the left and the right eye, but I've actually got it rotated through 90 degrees, which means it's now vertically interlaced. So I want to create a vertically interlaced image, and I will be able to see this in 3D in Krita without any extra software. All I need to do is create a 4x4 pixel image here. Let's create this. Now this would be different if you were using Photoshop, but basically you can do the same. I know, because I did it a long time ago. So I'm just creating an interlaced image here. So in Krita, what I do now is I go to Custom Pattern, Update Users Pattern. That is now a pattern. I now create a new layer. I fill with that pattern the entire layer, like so, and then I right click on this and select Convert to Transparency Mask. And now this has become a transparency mask for the right hand eye layer. Now the problem with this, and why I suggest anaglyph glasses are the best, is this only works at 100% view size, because any other size will not match the orientation of the screen. And the other problem is if you move 1 pixel to the left, if you move the screen 1 pixel to the left, you'll see the 3D will sort of flicker and alternate between them. Now that's far too small, so what I'm going to do is I'm going to resize this, scale image to new size, and I'm going to select 400%. And because I want to keep those nice chunky pixels, I'm going to select nearest neighbor here. Now that has got bigger, but my interlacing has also got bigger, and so that's no longer going to work with my 3D screen. So I now need to fill again with the proper pattern. That is now interlaced again. So if I now make sure I'm set to 100% view, that's now at the correct scale. And if I get my passive 3D glasses and put these on, and I move over to the screen you can't see, which I do apologize for. Yep, that is now in 3D. So I can now see that in stereoscopic 3D in the Krita application. Now the only problem with it is we can only view it at 100%. And if we move the screen like this, the 3D will toggle in and out and it will be going backwards. So that is great for a final preview to check your color. But the color code glasses are the best for your main work, because you can zoom in and out and everything will stay the same and there's no positioning problems there. But I think both are very worth having if you can get your hands on them. Now, the last thing we're going to discuss is how you can create an MPO file for your Nintendo DS. If I just go here, I've got my SD card from my Nintendo DS here, and if we just plug this in, here is our Nintendo DS here. This is the card from my Nintendo DS, and if we go to DCIM here, we've got some files. Now the first one is a sample that I took of one of my squids. So I've got these squid toys here. I thought I'd make a nice little test. So basically, if I drag this onto the Stereo Photo Maker, you can see it here, and it's currently being viewed in anaglyph mode. We've got all kinds of other options here, interlacing. So if we click here, this will go to side by side, and now you can see the two images that make up this 3D picture here. So here's I think this is the left eye and this is the right eye in this case. So this is the image pair. Now we can create our own image for this. All we need to do is go to File, Open Left Right Images, and we just need to select a pair of images that we can work with. Unfortunately, I've got them here. Now these are the original ones that I used, not the ones we just created, but we would just need to save those two separate layers as an L and an R image. If I select the L image here, it automatically says, hey, I found an R image, do you want to use it? So I just say yes. And now we've got our two images here, and we can now view these in anaglyph mode. If we just go, where is it? Not that one, this one. And we select colored or half colored, and that's our 3D image there. But if we want to save it as an MPO, we can do that. We just do File and we do Save MPO, and we've got an option here for Nintendo DS. I think maybe we need to select that. I'm not sure what it does. I don't believe we need to set the EXIF time, and we don't need to resize, but the Nintendo DS stretches the image horizontally, so I actually added a black border to the image when I exported this. All we need to do is go here and do Edit and then select Formatting, and we need to select the width and height of our image as the size of the image, which is 256 by 192. Then here we select 400 by 240, which is the size of the Nintendo DS screen in 3D mode, and we just select centering here horizontally and vertically and click OK. And now that's created some borders, and that means that when we export this, it will not crop the top and the bottom of the image. So all we do now is we do File, Save MPO File, and we can save this straight onto our DS here. And all we need to do is we need to make sure the file name is in the correct format, otherwise it won't see it. So basically we need to make sure the letters and the numbers are the same. So I'm just going to call this HNI0024 here. We don't need to create a matching JPEG, it doesn't seem to care about that. And then if I take out this SD card here, and if we just go over to the overhead camera again, And I'll just put this SD card into my 3DS here. And it's found that we've got another image now. And that's the image we just created there. So basically, even though we're creating an image with the anaglyph glasses, we are ending up with a full 3D image, and we can export it to the devices we need. Now, the last thing I want to show you is how we can actually create an optimized anaglyph which will have better color but still retain the 3D effect. All we need to do is, we can do this in Krita again. If we go properties here, and I'm going to use the red cyan glasses again. So if I do this here, and I'll just put my 3D glasses on. Now, at the moment, the 3D is pretty good, but the colors are very glarish because colors like this purple here, they come through the red eye very well, but very poorly through the cyan eye. And what we can do to fix this is alter the saturation. So if I go to filter and adjust and hue saturation, now basically I have to pick how much I'm going to trade off the color for the comfort of the eye. And a good starting point is 50%. That will halve the amount of color information, and it will make the image half gray. Now, if we made the image completely gray, the 3D would be fantastic, but the color would be gone, obviously. So basically, we've got to make a choice somewhere between that of how much color we want to lose. And if we select it right, we'll end up with an image with some color still and great 3D that is very comfortable on the eye. And 50% here is pretty reasonable in this case. The purple here, it was pink, but it's now purple. That's a lot more comfortable. It's still a little bit flickerish because of the difference between the two eyes, but the green and the yellow are all fantastic, and the 3D is really good. And that's what we can do. And again, we don't need any extra software to do this. You can do all of these kind of things with this 3D Stereo Maker here, but you don't need it if you don't want to. You can do it all with really any advanced image editing program, more advanced than MS Paint, basically. And there we go. So that's all I'm going to be covering today. I hope you've found this interesting. Maybe you didn't know anything about these, and maybe you'll feel like having a go with them now. The only other thing I would suggest to you is if you want to try taking your own 3D photos, that's really easy as well. All you need to do is, if you've got a camera, just move the camera to the left or the right as you're taking photos and take a sequence of them. Combine two of the photos together from different positions, and this, in the same way as I've shown you today, just change the color channels and you will end up with a 3D photo, hopefully. So yeah, it's all very easy to do. You don't really need any technology to do it or any software, and it's as cheap as a few dollars to buy a pair of glasses from Amazon or eBay. Anyway, I hope you've enjoyed this. If you have, please like and subscribe, because I have actually got more stereoscopic content coming, because my camera's flipped, because I'm working on a game that's going to be using stereoscopy. So that's why I've made this graphic, and that's why I thought I'd discuss stereoscopic anaglyph glasses today. Anyway, thanks for watching, and goodbye. If you've enjoyed this video today, please consider supporting my content. It takes 20 to 30 hours a week to keep making these videos. It's basically all I do when I'm not doing my day job, and it's only through the support of my patrons and the other sponsors that I'm able to continue justify doing it, essentially. You can back me on Patreon. I post a weekly update with the latest work on the current projects I'm doing. You can see one here, and also the newest videos. There's a large backlog of videos that are currently only available to the patrons, although they will all be available to everyone later on. And also, it's the backers who I ask when it comes to making decisions on how to change the content in the future, what new content to create, and things like that. You can see there was recently a survey of the backers, so I can plan next year's content. As well as Patreon, you can now become a member of my channel on YouTube. There's a join button you should see just below this video. You can use that. YouTube backers get the same content as Patreon. I just post it through the YouTube interface instead of the Patreon one. It's the same content every week. Also, if you prefer, you can go to my Teespring store and you can get some Chibi Akuma's merchandise or some Learn ASM merchandise if you prefer, if that's how you would like to back me. Links for all three are in the description of this video below. Anyway, whatever you decide to do, I hope you've really enjoyed this video. Thanks for watching today, and goodbye.